Look at this exam paper. It's not just a test, it's a literal boss fight. And today, we are bypassing the standard textbook reading and going straight for the mark scheme heist for Cambridge IGCSE Physics 0625, Zero Fluff. If you want to know exactly how to secure top band marks in your measurements and UNIS calculations and avoid the traps that destroy grade boundaries, you are in the right place. Let's get into it.
Okay, consider this deceptively simple calculation. Finding the area of a rectangle where the length is 20 centimeters and the width is 10 millimeters. Sounds incredibly easy, right? It looks like a basic primary school math question, but here's the thing. This exact scenario acts as a fatal trap for thousands of physics students every single year. They see two numbers, they multiply them together, and they completely shatter their grade boundaries before they've even finished the first page of the paper.
Okay, let's dive into this. A simple answer of 200 means you just walked right into the trap and scored 0 marks. A tiny unit inconsistency, like multiplying centimeters directly with millimeters, literally costs you entire grades. On the right side, we have the top band execution, 20 square centimeters. It's a really subtle difference in strategy, but it represents the entire gap between struggling and acing the exam. In Physics 0625, the numbers mean absolutely nothing without their units.
To pull off this exam heist, you need your primary arsenal. This is your foundation. The international SI system was agreed upon so that scientists, and more importantly for you, examiners, can easily compare the size of variables. You must know these base SI units called length or distance, measured in meters represented by a lowercase m, mass is in kilograms or kilogram, time is in seconds or s. These are your non-negotiables. If a question gives you kilometers or hours, your first instinct should be a blaring warning siren.
But the boss level gets harder because we don't just use base units, we combine them into derived units. Basically, a derived unit is just a unit based on a calculation. Take speed, for example. It's the number of meters traveled in each second, written as m/s. That / indicates division. If you try to calculate speed using a distance in meters, but a time in hours, your calculation will instantly break. Honestly, mismatched units are the #1 reason students lose straightforward marks. Let's quickly run through the rest of your essential SI unit hit list. To survive the 0625 papers, you must recognize these instantly. Force is newtons, energy is joules, power is watts, temperature is degrees Celsius, frequency is hertz, potential difference is volts, electric current is amperes, resistance is ohms, and electric charge is coulombs. Seriously, burn this list into your memory. Writing these symbols quickly and accurately is your absolute shield against losing careless marks.
Now pay close attention to this next part. In just a few minutes, I am going to reveal the exact hidden examiner clue that decides whether you land in the bottom band or the top band for a question. It's a really subtle trick they hide in the prompt, and it changes your answer completely. But to actually spot that clue, you need a core framework first. And this brilliantly illustrates the 4-step top band answer framework. Think of it as your master key. First, you identify the underlying physics concept. Second, you extract the exact evidence or data from the prompt. Third, you apply scientific reasoning, and this is exactly where your equations and unit conversions come into play. And fourth, you write it down using precise examiner wording. Let's go ahead and apply this framework to our initial track. Visualizing this on a ruler, we have a length of 20 centimeters and a width of 10 millimeters. The equation for area is length multiplied by width. But wait, before you even think about multiplying, your scientific reasoning step has to kick in. The units absolutely must match. 10 millimeters is exactly equal to 1 centimeter. By taking just a second to convert the width to 1 centimeter before calculating, you ensure complete consistency.
So the crucial point is perfectly highlighted right here. Grab your mental red pen for a second. On the left, the flawed student answer ignores the units completely. 20 times 10 is 200. This student failed the mini-boss because they skipped step 3 of our framework, reasoning through the unit conversion. Now look on the right, the improved answer clearly states the conversion. Width is 10 millimeters, which is 1 centimeter. The final calculation is 20 times 1, giving a perfect 20 square centimeters. Now that you've mastered linear conversions, the examiner is going to escalate the stakes. We are transitioning into the ultimate trap. This is perhaps the most commonly failed calculation in the entire syllabus, converting square and cubic units. This is the exact spot where even the A-star students totally freeze up under exam pressure.
10,000. Yeah, let that massive number sink in for a moment. When you are converting from square centimeters to square meters, you do not simply divide by 100. Because an area is two-dimensional, you are dividing by 100 squared. There are 10,000 square centimeters in 1 square meter. If you forget this, your answer will be off by 2 entire decimal places, and poof, your marks will just vanish.
All right, time for an interactive pause and predict moment. Here is your boss level challenge. You are faced with a three-dimensional scenario now. You have a volume of 50,000 cubic centimeters. How exactly do you convert this into cubic meters? Think about the logic we literally just applied to area. Pause this explainer for a second and lock in your prediction.
Did you guess it? 1 million. To convert from cubic centimeters to cubic meters, you must divide by 1 million. Because a volume is three-dimensional, it is 100 times 100 times 100. The sheer scale of this conversion difference is absolutely staggering, and it's exactly why examiners love testing it so much. It separates the students who just memorized a basic rule from the students who truly understand physical dimensions.
Let's move to the execution and see how this framework builds into an examiner-style correction step by step. Step 1. Identify the original value, which is 50,000 cubic centimeters. Step 2. Recall that massive conversion factor for volume. Step 3. Process the calculation by dividing 50,000 by 1 million. And Step 4. Arrive at the final flawless answer of 0.05 cubic meters.
Now remember that open loop from earlier, the hidden examiner clue? Well, here it is, perfectly summarized by this quote. Using the same units means that we can compare the size of variables very easily. The ultimate examiner clue is unit inconsistency in the prompt itself. If a question gives you a distance in kilometers but asks for an answer in meters per second, that mixed unit is a deliberate, giant, flashing neon sign from the examiner. They are practically screaming at you to convert before you calculate. Spotting that mixed unit is the absolute key to unlocking the top mark band.
So congratulations on surviving the units boss. By locking down your SI units, verifying consistency, and mastering those massive square and cubic conversions, you've just secured a major strategic advantage. But listen, our exam heist isn't quite over. While you've mastered the math, there is a completely new unresolved threat waiting for you on the actual exam paper, the fatal command word traps.
If you don't know the precise difference between explain, describe, and evaluate, all your perfect calculations won't save your final grade. The next boss requires you to master these command words. It is absolutely mandatory for your success. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click on the next explainer right now, and let's decode those command words together. Because ultimately, are you actually answering the question they asked, or just the one you hoped they asked? See you over there.